Up to this point, the pattern maker has studied the drawing for the one-cylinder water-cooled motor block. And from the drawing, he has visualized the casting. The pattern, with its core prints, has also been visualized. And it has been accurately laid out. The crankcase and barrel core have been visualized. Because the drag half of the core could not be drawn in one piece, it was decided to split the drag half into two sections. These core boxes were added to the layout. The pattern maker's next step is to get a complete mental picture of the water jacket cores by studying the drawing. Let's follow him again as he thinks it out.
This water jacket shape is complicated some by the ports. I'll have to check each view carefully. But I know there will be two main sections, one on each side of the parting line. Let's see. I'll check the cope half first. Looking at it from the top, the cope half will be like this. And I'll print through the top to form these holes. From this end view, I can see the shape of the core and the prints. From the other end view, it looks the same. By combining these views in my mind, I can see that the core will look like this. So far, so good.
On his layout, the pattern maker makes any necessary additions for the cope half of the water jacket core box. This is done in each view on the layout. Next, the pattern maker goes back to the drawing to study the shape of the drag half of the water jacket.
The top view gives me this shape for the drag half. And from this, I can see the top view of the core. But the top view alone isn't enough. From the end view, the core shape and the prints ought to be like this. And so I can see the core in this view. From the other end, it'll be the same. Now, let's see this side view. The shape is clear enough, and so are the prints. This view of the core would make it look about like this. But now here's where those little port cores come in. I believe they'll have to be separate cores, probably pasted to the water jacket core. The sectional views show these ports very clearly, but I'll check the other views too. The top view shows me this shape. This end view shows one of the ports, while the other end view shows the other port. How is this core going to look when the port cores are pasted into the water jacket core? Well, I guess that part's all right. They'll paste up okay. But here's something. This half of the water jacket core can't be drawn in one piece. The core will have to be split. This makes two sections which can be pasted together after they are made. That makes quite a lot of pasting, but I think it's necessary for this job. The core box for this section of the drag half of the water jacket core can be drawn easily. But drawing the core box for the other section of the drag half of the water jacket is a different problem. Because of the shape of this part of the core, it can't be drawn without a loose piece in the core box. Let's see. How are that core box and loose piece going to work? The loose piece will have to fit the box this way, with the inside shaped to form the projecting part of the core. When the core is made, sand will be rammed into the pocket under the loose piece. Then the box can be drawn, leaving the loose piece with the core as support. After the core is baked, the loose piece can be drawn.
When the visualization is complete, the pattern maker adds any necessary lines to the layout to complete the core boxes for the drag half of the water jacket. Then he goes on with the port cores.
It's not hard to visualize this port core and its core box. I think this is the best way to split the core box. And the other port core and core box can be designed the same general way.
The pattern maker makes the necessary additions to the layout for the port cores. Then he checks carefully to see how these cores will fit together in the mold.
Chaplets will be needed in two places to keep the water jacket cores from sagging. This ensures the proper thickness for the metal wall at these points. However, it does not solve the problem of preserving the thickness of the vertical parts of this wall. But I think I'll let this problem go for a moment, because I want to visualize the cores in the mold. I just wonder if the core prints as I've planned them will give enough support. These cores will be heavy. The large core print on the end will give enough support there, but it looks to me as if more support will be needed at the other end. On the bottom, where most of the weight will be, these small core prints probably won't give enough bearing surface. I'm afraid the weight of the core assembly will push the prints down into the sand. At this end of the mold, a large core print with the smaller water jacket prints set into it might provide good support. I think I'll call the foundry foreman and have him send in a man to show me how he'd prefer to have the cores supported.
Working together, the pattern maker and foundryman figure out the best way to support the cores.
A ram-up core would certainly help to support the core on the bottom of the mold. And this is a good opportunity for it, because the core prints for the inspection plate openings and ports can be fitted into it for positive support and location.
A ram-up core is actually rammed up with the pattern. When the pattern is drawn, the ram-up core is left in the mold. This gives solid support for the core and assures foolproof core setting.
With the support of the ram-up core underneath and the large prints at each end, the crankshaft and camshaft holes won't be needed for support. They can be kissed through. On the crankcase core, these prints will be metal thickness only. There will be no corresponding core prints on the pattern. But the ram-up core can be smaller than I figured at first, and still give enough support. A smaller ram-up core will be less work to make. Part of one of the inspection plate opening core prints can then be made to kiss through where it extends outside the ram-up core.
The ram-up core is added to the layout, and the layout of the inspection plate opening core print is changed to show that part of it kisses through.
Then, as I see it, this is what the drag half of the crankcase core is going to look like, with part of the core print kissed through, and part with a full print to match the ram-up core.
The problem of maintaining the thickness of the vertical portions of the metal wall is now considered. The foundryman suggests that the end core be made into a setup core, and that the ram-up core be extended to meet it. Now, the water jacket core unit cannot shift, and the vertical wall thickness will be maintained. The setup core has another advantage. All the sections that make up the drag half of the water jacket core can be assembled accurately as a unit and pasted into the setup core. The entire drag half of the water jacket core can then be placed in the mold as a unit. The layout must be changed to redesign the setup core.
Now, let's see. I'll have to check the layout of the top view. Each opening here will have a print on the core. These prints will fit into depressions in the setup core. The barrel core can go all the way through the setup core. This will give better support for the crankcase core. From the layout of the side view, I can get the shape of the bottom part of the setup core and the ram-up core. So, I can imagine the ram-up core as it will be when finished. Now, from the layout of the top view, I can visualize the setup core, and also how the ram-up and setup cores will fit together in the mold. They can be parted along the center lines of the port openings. The cope half of the setup core will fit on top of the drag half. Well, I guess that finishes the design of the ram-up and setup cores.
With the ram-up and setup cores corrected on the layout is complete. In many shops, each layout is approved by a checker or by the foreman. Mistakes found now are easily and economically corrected. The checker makes sure that the layout is accurate and meets all specifications. He sees that nothing has been overlooked or left out. When the checker puts his OK on the layout, that means that the next step is the actual construction of the pattern and core boxes.